few important points in the coordinate system, like general point, unit vectors, etc. etc. First one, in every coordinate system, what is the general point to locate all regions in the space? Already you know the answer. So in rectangular coordinate system, general point is px comma y comma z. So by changing x values, by changing y values, by changing z values, you can locate any point in the universe. So universe means space actually. Here x represents length, y represents width, z represents height. So no need to write them. Now what is the general point to locate all the regions, or otherwise all the locations in the universe or otherwise space in cylindrical system? So in cylindrical system, that general point is P rho comma pi comma z. Already we have discussed the same thing. So now what is rho here? Actually rho is radius of circle or otherwise cylinder, and this is also called as for example, I was telling you this is z axis. Now you draw a circle, and you draw a circle of how much radius? Rho radius. Then here comes one point, the perpendicular distance, that means 90 degrees distance from z axis to this location is rho, and anyway angle is phi for this point, that is 90 degrees here angle you can say. Don't bother about angle, because for a circle here angle will be changing. Okay, for this point angle 0, for this point on the y axis angle 90, like that keep changing. Now height is z. So that means I have taken here, this is y axis, this is x axis. I have taken this circle, I have drawn this circle at z height actually. That is the meaning. At z height I have drawn this circle. So this is the point P, rho comma pi comma z. Now what is rho? Radius of circle. If you draw a cylinder like this, then that becomes radius of cylinder. In other way, rho is perpendicular distance, that means 90 degrees perpendicular distance, this one. Now this rho is making 90 degrees to this z axis. So perpendicular distance from z axis to the point P. Already I told you rho value on the z axis is 0, because radius measurement starts from z axis. Wherever radius measurement starts, that means that is z axis, their radius is 0. Then you go like this, radius is increasing. So where rho is also called as perpendicular, this is the symbol, perpendicular distance from z axis to P rho comma pi comma z location. Okay, that is also correct. Now what is pi here? Here pi is nothing but horizontal angle. It is also called as otherwise azimuth angle. Dear friends. Now how you measure this? Pi is angle between, already you have seen angle between x axis and rho line, right dear friends? So this already we have studied this one. Now what is Z? Z is height actually. Otherwise you can write like this. Perpendicular distance from XY plane. Dear students, on XY plane, can you tell me what is height? 0, because Z axis starts from XY plane. So Z is perpendicular distance from XY plane where Z value is 0 to the point rho comma pi comma Z. So here to here distance is Z actually. Here also distance is how much? Here to here distance is how much from XY plane? Z only. That is height actually. Now coming to the spherical system. Spherical system. I am not writing completely. Simply SPH I am writing. Spherical system. In spherical system, once again I am telling students, change XYZ. You can locate all the locations of space. Similarly, you change rho by Z. You can locate all the locations of space. That also we will see after some time. Similarly, what is the general point in spherical system? That is r comma theta comma pi. Here change r theta pi values. Then you can locate all the locations in the space. So what is r here? Here r is radius of a sphere. Like this it was. Diagram was like this. So if you remember, this one, this is x-axis, this is y-axis, this is z-axis, and this is r, and this is theta, and this is the point r comma theta comma pi. If you project this, you will get here like this rho. This is angle pi, horizontal angle. Okay. Now already you know that rho is equal to r sin theta in projections. Let us not waste our time. Already you know that. So r is radius of sphere. Okay. It is also called as shortest distance from, this is origin, this is P, from O to P. So this is shortest distance from origin to this point, this radius of sphere, or otherwise it is also called as shortest distance from origin to the location P, this P point, OP. Okay, dear friends. That means OP is how much here? That is R actually. OP is R. So here theta. Theta name is vertical angle. It is also called as elevation angle. Here pi is called horizontal angle, otherwise azimuth angle. Here theta is called vertical angle, otherwise elevation angle. How you measure this? Theta is angle between z-axis and OP line, that is also called as R line. This R line is nothing but O to P distance is R, so OP line that is. Okay. Now here pi is same as this coordinate system, that is horizontal angle, otherwise azimuth angle. So pi is angle between x-axis, this x-axis, and the rho line. Here what is rho in terms of r theta pi? Already you have seen in the conversions, rho sin theta. Did you remember? I have projected this here and already in conversions. Again and again we should not discuss. So this pi is same as cylindrical system. Same as cylindrical system. I will be explaining how to change r theta pi, all those things, don't worry. This is one point we have discussed, this is the point. Now next point we will discuss what are the shapes of the surfaces. We will see that. Now let us see the shapes of the surfaces. Already I told you very clearly that if one constant is there, that is surface. That means two variables will be there. Now let us see that. So here I am drawing one diagram, simple diagram. This is y-axis. This is z-axis. This one is x-axis. Okay. Now I will take here dy width. How much width? dy. Then I am taking here dz height. So if you see carefully, parallel to x-axis, I will take, this line is parallel to x-axis. I will take dx. Now I will draw a line parallel to the y-axis like this. This line is parallel to y-axis. So this is also dy. This is also dy. Now here this is actually dz. This one is dz. So here I will draw a line called dz. Approximately this one are same. And here I will draw a line parallel to the x-axis. This one. Of course, it is little bit like this. That is why like this. Because I have to make this dy. Then this one is dz. This is also dz. This is also dz. This is also dz. Now this one is dx, and parallel to this dx, this is also dx. Anyway, no need to write at these many locations, so I will remove them. So parallel to x-axis, small length I have taken, so dx, and this is dy, and this is dz. So dear students, I can take this as a x length also, this as a y length also, and this as a z length also. Actually all are called lengths only. But this is also meter. So meter means length actually. But we call this as a length, we call this as a width, we call this as a height. Okay. Now, if you take this surface like this surface is on which plane? Answer, xy plane. For this surface, what is z value? For this surface, what is z value? For this surface, z value is 0 because xy plane, from xy plane, z axis starts. Z value is 0. What is 0? Constant. So z is equal to constant. Okay? Z is equal to constant. Similarly, you take this surface. For this surface, y is variable. This is y, and z is variable. But x value is 0 on this surface. So x is equal to 0. What is 0 actually? Constant. Similarly, for this surface, x is variable and here z is variable. So you draw vertical lines like this and you draw the lines parallel to the x-axis. So on this surface, this is xz surface. On this surface, y value is 0 actually. What is 0, dear students? 0 is constant, so this is called y is equal to constant surface. Now I want to tell you, so if you make anywhere x constant, that means x is equal to constant, surface is rectangular surface. Of course, if this same, that is square surface. But no need to write square surface because square is special case of rectangle. Rectangle is general shape. So x equal to constant surface is rectangular surface. Okay. Similarly, y is equal to constant surface, z is equal to constant surface. They are also rectangle shape you have seen. Right, dear students. Now let us go to the cylindrical coordinate system. Here first I will take a z axis like this. I will take z axis. Now if I take this as a y axis and if I take this as a x axis, so x y z axis, let me draw a cylinder here. So here I am drawing a cylinder actually. Okay, it is better first I will draw a cylinder, then I will take x y z. That will be very simple. So this is cylinder, otherwise shape will be changed. You can't observe carefully. Okay, this is cylinder. Now the center of cylinder is z axis. Now here is the y axis. Here is the x axis. If you see carefully, radius measurement starts from z axis. So that is why here radius is 0. Then you go like this. For example, radius is 1 meter, let us say 1 meter cylinder. Now here there is a side surface like this for cylinder, like this, and this is cylinder surface. For example, this is also a cylinder, you can see here. Okay, this is a cylinder. Now this is the side surface. So for this side surface, radius is constant, rho is equal to 1. Sorry. So rho is equal to constant surface is side surface, that is cylindrical surface. For example, bottom side you see that is circular surface, because for this surface height is here the cylinder is starting. So for this surface, circular surface, that is, so for this circular surface z is equal to 0. So here 0 is constant. Similarly, let us say cylinder height is 5 meter. Now here this is z is equal to 0 circular surface, and this is once again one more circular surface is there here. For this circular surface z is equal to 5. This 5 is also constant, dear students. So z is equal to constant in the cylindrical system is a circular surface, and rho is equal to constant is a cylindrical surface. Now you take here cylinder like this. Now this is the z axis and this one is y axis, this one is x axis. If I take here one line like this, then this is pi angle. Let us take this pi is equal to 30 degrees. Otherwise center is there, means let us take this as a 45 degrees. Here there is no place, I am writing that 45 degrees here. Now here also you draw a line like this, and here also from the center this is 45 degrees. Now this is actually for this surface, angle pi is always 45 degrees, because these lines all are making 45 degrees with the x-axis. So that is 45 is what actually constant. So here pi is equal to constant surface is a rectangular surface. Okay, dear students, I will show you here. What I want to tell you is that if you take a rectangular surface like this rectangular surface, and this is x-axis, y-axis, z-axis, put like this, then angle is 0. Like this you do 90 degrees, like this you do 180, like this 270, 360. So if you take a rectangular surface and rotate like this, then you get a cylinder. Then once if you stop rotating like this, then angle is 45. Then on this surface, anywhere angle is 45. So it looks like a rectangular surface. Okay, dear students. So now you have observed them. Now let us write. So rho is equal to constant surface. Rho is equal to constant surface is a cylindrical surface. Cylindrical surface. Dear students, I told you again and again, no need to discuss. For example, you see the statement x equal to constant means this one. For that, y comma z are variables. So here for this surface, y is variable and also z is also variable. Already we have discussed. Surface has one constant, that is x, and two variables y, z. Like this, for y is equal to constant surface, x, z are variables. For z is equal to constant surface, x comma y are variables. Similarly, here also for rho is equal to constant surface, phi comma z are variables. So for a side surface, angle is variable and height is also variable. Like that, no need to tell every time. If one is constant, then on that surface, that means side surface, other two are variables, they are phi comma z. So rho is equal to constant surface is a cylindrical surface. Now pi is equal to constant surface is a, I have shown here, rectangular surface, and z is equal to constant surface is a circular surface, otherwise a circular disc, you can say circular surface. Now let us go to the spherical coordinate system. In the spherical coordinate system, if you make r constant, theta constant, then phi constant, what are those surfaces? Let us see now. So like this, in spherical system, actually you take a sphere like this. Okay, dear friends. Now let us take radius. This is center. Radius is 0 here, and let us take the spherical surface is 1 meter radius. Now everywhere, here also 1 meter radius, here also 1 meter radius. That means 1 is constant. So here r is equal to constant surface is a spherical surface. You have to remember all these things, students. Spherical surface, because anywhere if football surface is there, or otherwise spherical surface is there, for that spherical surface radius is constant. If you take football, from the center to the football surface, radius is also always constant. Now you take this one. What is this actually? This is cone, C-O-N-E. Now this one is z-axis, center. Okay, this is z-axis. For example, if I take this theta as a 30 degrees, here 30, here 45, here like this means 90, okay? Because theta is measured from z-axis, that is why I kept arrow mark. Theta is 0 on the z-axis, like this you are going 30 degrees you went. So what is 30 degrees actually? 30 degrees is constant. Now this side also, how much angle you have? Same angle, theta, 30 degrees. Now you take a conical surface. Ice cream cone is there, no? You will eat cone ice cream. That one, this one. So like this, you draw lines like this, and up to origin you have to draw. But I have written theta here, so I am not drawing. You have to draw them up to origin. So this is conical surface. For conical surface, theta is constant actually. So theta is a constant surface is a conical surface. Which surface? Conical surface. So you have to remember, students, for cones, what you have to remember? If angle comes and there is a surface, then if angle comes and there is a rectangular surface, that is cylindrical coordinate system, you have to remember. Next one. If an angle comes, then conical surface comes, that is spherical system. Similarly, one more statement. If angle comes, then semicircle comes, that is spherical system, and that is horizontal angle. We will discuss that now. So here, if you take a, if you take a sphere, and from that sphere you take a semicircle like this, and for this semicircle, dear students, like this it is. For this semicircle, otherwise I will do one thing, no? I will not put curved lines. I will put straight lines like this, okay? So that you will not be confused. So this is semicircular surface, okay? Now for this semicircular surface, pi is constant. So pi is constant, pi is equal to constant surface is a semicircular surface. I will show you like this. If you take a rectangular surface and rotate horizontally, then you get a cylinder. Now, if you take a semicircular surface like this and put on the x-axis, then horizontal angle is 0. Then rotate 90 degrees, then you get 1/4 of the sphere. Then 180 degrees, half of the sphere. 3/4 of the sphere, full sphere. Now, while rotating, you stop that, then horizontal angle is constant. So that is this one. Pi is equal to constant surface is a semicircular surface. Okay, so this is all about the shapes of the surfaces. Now next we are going to discuss what is the range. We will discuss. Now let us discuss unit vector, students. You know that in rectangular coordinate system, unit vectors are ax cap and ay cap and az cap. Already you know them. So, and also they are perpendicular to each other. That also you know. I am showing here, you will take this as a y-axis. You will take this as a y-axis. So that is why y value 0 here. I will tell you this is z-axis. So y value 0 here. In this direction y value increases. So that is why this is ay cap. And this is z-axis actually. So here z value is 0 at origin. Like this z value increases. So this is a z cap. Now this is x-axis out of the board. So x value increases in this direction. So dot means already I told you, dot means out of the board here, for you students, out of the page. So kagaz hai page. So here x-axis is there out of the board. Again they are mutually perpendicular. That means angle between them is 90 degrees. Okay. Now let us talk of a cylindrical system. In cylindrical system, aero cap and a pi cap and az cap are the unit vectors, and once again they are perpendicular to each other. I will show you how. Now let us write one by one. Now first one, this is a z-axis. On the z-axis radius is 0 here. Now if you go like this, rho increases. If you go like this, rho increases in this direction. So that is why this is aero cap. So my dear students, in this direction, for example, rho is equal to 1 meter, rho is equal to 2 meter, here rho is equal to 0. So in this direction, radius is increasing. This is aero cap, and this one is minus aero cap. So this is called radial vector. Radial means in the direction of radius. So aero cap is radially outward from z-axis. Radially means in the direction of radius. Why radially outward from z-axis? Because rho increases. So aero cap is radially outward from z-axis. Even if you take a cylinder here, this is z-axis and this is radius 0. For example, you have taken rho is equal to 1 meter cylinder, then in this direction you have aero cap, because you go away from the cylinder, radius increases. Like this also, you go away from the cylinder, radius increases, like this also. That means you go away from z-axis like this, like this, like this, in any direction, like this, like this, like this. You go away from the z-axis, then that is aero cap you get. Okay. So now radially outward from z-axis, or otherwise radially outward from cylindrical surface, both are correct. Now dear students, coming to the a pi cap, so a pi cap is horizontal angle. So horizontal angle it is. So horizontally, always angles give circles. So whenever you increase the angle, that gives circles. So a pi cap is horizontally circular in anti-clockwise direction. In anti-clockwise direction. In anti-clockwise direction on a circular line, or otherwise on a cylindrical surface, you can say on a cylindrical surface, dear students. So basically I am writing this here like this. This is the cylinder. Now actually this one is y-axis, this one is x-axis, this one is z-axis. So dear students, here anywhere you draw a circle like this, on the cylinder, then in this direction pi increases. So that is why that is a pi cap, because here pi is equal to 0 degrees. Like this you go now, then here pi is equal to 90 degrees. On this circular line here, pi is increasing. So that is why that is why this is like this, no, like this pi is increasing, so that is why this is a pi cap. So this is called clockwise direction, this one is called clockwise, and this one is called anti-clockwise. So like this. So this is also a pi cap, this is also a pi cap, opposite will be minus a pi cap. So in this way, no need to discuss again. Here z axis is there, so if z axis is there like this, then automatically this z axis, this is az cap here, students. Okay, now az cap is in the direction of z axis. Now I will show you how a rho cap, a pi cap, az cap, they are perpendicular to each other. So now students, you take this as a x-axis, this one, this is y-axis, this one is z-axis. I am actually, here you can see I am holding the x-axis and y-axis, x-axis and y-axis. Here board is not there, I am taking them onto the board. See carefully, this is x, this is y, so this is x, like this, this is x, this is y, this is z. So this is x-axis I am taking, and this is y-axis I am taking, that means ay cap. This x-axis I am taking means this is ax cap. Okay, now out of the board is az cap, out of the board like this, it is az cap. Now if I draw a circle here like this, circle here like this, if I draw a circle like this, now here on the z-axis radius is 0, here radius is increasing like this. So just at single location I am observing the directions. At this location, actually students, very simple, this is center of the circle, the z-axis. From the center line of the circle, if I go away, then radius increases. That is why at this location, this is a rho cap, dear students, a rho cap. Now, actually, like this, on the circle, like this, a pi cap goes like this. Actually, this is the circle. Okay. Now, a pi cap goes like this. At this location, that a pi cap is a tangential line to this circle. Tangential line to the circle. Tangential line means the line which touches this circle at single location. Now, the angle between them, this is a tangential line to the circle at this location, and this is radial line to the circle. So tangential line to the circle and radial line to the circle, both are perpendicular. And this out of the board is z-axis. So dot, matlab out of the board. So that is az cap. Now again they are mutually perpendicular, you can see. So I am showing here, this is a rho cap at this location. This is a pi cap. Then this is az cap. They are mutually perpendicular. Then if circle rotates, they will be rotating like this on the circle. Like this they will be rotating. But always they make 90 degrees, 90 degrees, 90 degrees. So mutually perpendicular. Now let us talk of unit vectors in the spherical coordinate system. So in spherical system, crows are shouting actually. It is morning 3 o'clock हो रहा है, इसलिए कौवा है, कौ कर रहा है. Right, students? Because at daytime lot of noise is there, that is why recording is going on at night time. Anyway, now in the spherical system, dear students, a rho cap, a pi cap, and az cap, they are the unit vectors, actually spherical, no? A r cap, and A theta cap and A pi cap. Once again, they are mutually perpendicular. I will show you how. Now, first let us study what is AR cap and what is A theta cap and what is A pi cap. Let us study that. So anyway, no need to explain you. Already at the beginning I have explained. AR cap means unit vector in the direction of increasing R value. A theta cap means unit vector in the direction of increasing theta value. A pi cap means unit vector in the direction of increasing pi value. So here A rho cap means unit vector in the direction of increasing rho value, like that. So if I take this as a origin, this one, origin. Actually, I told you origin means 0, 0, 0. So radius value for the origin is 0. Now you go like this, then radius increases here. For example, radius 1, radius 0, radius 1, like this. So that is why AR cap is radius increasing like this. So that is why it is radially outward from the origin. Radially means in the direction of radius. So, for example, one more example I will take. Here you take a sphere like this. Now you students know that for a spherical surface, radius is constant. For example, this is center, so radius 0, and here radius is equal to 1. Anywhere on this sphere, radius is 1. Now you go away from this sphere like this, like this, like this. In any direction you go away from this sphere, then radius increases. That is why that is AR cap. So that is AR cap like this. And you go towards the origin, then radius decreases. That is minus AR. So here, dear students, what is AR cap? AR cap is unit vector. It is radially outward from origin, or otherwise from spherical surface, because this is spherical surface. So radially means in the direction of radius. Now actually you have to study these things carefully, students, so that in mathematics also you will learn so many things. So both the things will become easy. Now let us talk of A theta. Students, I told you already, if you take a sphere like this, then this is the z-axis. On the z-axis, theta is 0. I am right. So now you take vertical circles like this. Vertical angle, students, angle always give circle actually. Angle gives circle. Vertical angle give vertical circle. Horizontal angle give horizontal circle. One thing is common. Angle gives circle. Then horizontal angle gives horizontal circle like this. And vertical angle gives vertical circle. So now theta is equal to, for example, I will give the locations. Here at this location, theta value is how much? 0. Why? It is on the z-axis. Actually it is R0. R0 means origin it is. Now here, for example, theta is how much for this location? Let us say theta is 30 degrees. For this location, how much from here angle? 60 degrees. For this location, how much? 90 degrees. That means in this direction, theta is increasing. So that is why, like this, this is all A theta cap. A theta cap. That means theta is increasing like this. So how will you write that? A theta cap is vertically circular vertically circular in downward direction. In downward direction on a spherical surface. Very simple, students. Theta angle, that is why circle. It is vertical angle, vertical circle. In down direction, angle increases. Now, no need to discuss. If you take a cylinder, on the cylinder, this is a pi cap. Now, if you take a sphere like this, on the sphere, if you take a sphere like this, on the sphere, here you are taking horizontal circles on the cylinder, but here you have to take horizontal circles on the sphere like this. Like this, horizontal circles you have to take. Like this, you have to take. Like this. So, one thing is common. Here also horizontal angle, here also horizontal angle. But here horizontal circles on the cylinder in cylindrical coordinate system, horizontal circles on the sphere in spherical system. So this one is this. They are actually a pi cap. So a pi cap, same as previous statement, is horizontally circular. Is horizontally circular in anti-clockwise direction on a spherical surface. Now I will show you how they are perpendicular to each other. Now let me draw a sphere like this. If you see carefully, this is the sphere. Okay, like this I am drawing. Now at the center, that means here, r is equal to 0. Here if I go like this, then radius is increasing. That is why it is AR cap. I am right now. So here radius 0, radius 1, radius 2, like this, radius increasing, that is AR cap. This AR cap always make 90 degrees to this spherical surface at the location wherever it cuts this spherical surface. जिस जगह में ये रेडियस लाइन है स्फेरिकल सरफेस से बाहर निकलता है, उस जगह में 90 डिग्री एंगल करके बाहर निकलता है, सिर्फ उस जगह में. और मैं क्या बोल रहा थे, व्हाट आई वाज टेलिंग यू इज दैट नाउ दिस is z axis. Now like this, this vertically downwards is a theta. Now whenever this comes here, that becomes a vertical downward tangential line. At this location I am observing the directions. At this location, as it comes like this, now it is coming like this, downward like this. So that is a theta. Students, at this location a theta is vertical tangential line and downwards, because in downwards the angle increases, vertical angle. Now already I told you that like this, you see, like this coming a pi, that is a pi. Now when it comes, it enters into the board. Once again I am showing, like this it is coming. Actually you have to imagine one sphere here. On that sphere, this is horizontal circle, like this, it goes and it enters into the board. So into the board means cross rotation. Cross symbol indicates into the page, otherwise board. So here into the board, that means cross. I will remove this arrow marker. So this cross is a pi cap at this location. Actually, here there is a circle like this. Like this, if you want, I will draw the circle like this. One circle is there, like this. Like this it is going. Now, a pi cap is like this. Now when it goes here, it will be entering into the board. Okay. So now ultimately at this location, this is AR cap and this is A theta cap and this one is A pi cap. This one into the board. So like this they are, like this. So into the board that is. So they are always like this. This is AR cap, this is A theta and this is like this. At this location they are like this. Anywhere they are like this only. They will be moving like this. So ultimately don't bother much. I told you in rectangular system AX, AY, AZ are mutually perpendicular. In cylindrical also A rho, A pi, AZ are mutually perpendicular. In spherical also they are mutually perpendicular. Okay. Now we have to discuss next fifth point. We have to discuss differential lengths and dl bar, ds bar, dv equations we have to discuss. Okay. So dear students, now let us discuss differential lengths in the cylindrical system. Okay. Now cylindrical system. Differential length means small lengths in rho direction, pi direction, z direction. Now for this what I am doing, I am taking one cylinder here, like this. Okay. Now this one is y-axis. So this one is x-axis. So central one is actually z-axis. Now here actually what I am doing, this is the center and here we have radius line and here also we have radius line. Now I am projecting them here like this. Here this is rho and this one is also rho. Now let us take this is angle pi. So automatically this angle is d pi. So it has d pi angle. Okay. I will write this here d pi angle. This angle is d pi. D pi. This angle is nothing but d pi here. Now what to do? Differential lengths means what here? Actually differential lengths in rho direction, pi direction and z direction. Now let us see what are they. Actually this is rho. Total it is rho. I am writing here. This one is rho. This is also rho. Now what you do? Here you take a very small radius that is called d rho. Then this is also d rho only. Now what I do? Here I will take small height that is dz actually. So then this much height. So this is also dz only. This is also dz only. Now here also you take like that. So here also you take that much dz. So this is dz. So that much you take. Now this one is also dz. Now here if you see, let me finish this d rho. Here this is d rho, this is also d rho, this is also parallel to that, that is also d rho. Glue on. This black line is dz, this is also dz, this is also dz. Now let us see this red line here, this one and this one and this one, all are this one only. Okay, this one, this one, this one, this one, this one. Now that is actually differential volume here. So now let me tell you differential lengths. First you see this one, this for example, here if r radius is there, r is the radius, then I am rotating this line how much angle? 90, 180, 270, 360, like this I am rotating. Okay, how much angle I am rotating? 2 pi radians. Then I got a circle here, circle here. So now what is the length of circular line? That is nothing but circumference. So that circumference is nothing but this circular line. The circumference is nothing but total angle multiplied with radius. So how much angle we have rotated? 2 pi radians. And what is the radius? R. So 2 pi r. Now similarly, if there is a rho radius, then I am rotating this like this. How much angle I am rotating? D pi angle I am rotating. Then this is called differential length in pi direction. Why like that? Because in this direction pi angle is increasing, otherwise pi angle is changing, right? So then what is that length? This is the formula. Angle, how much angle you have rotated? So d pi angle multiplied with radius. So that is nothing but rho into d pi. I am saying differential length. Length means meters. So rho is meters. D pi means angle, that is not a meter. Simply radian, that is radian into meter is meter actually. So this is the differential length in pi direction. So dear students, similarly here, what is this length here? This is rho d pi. Rho d pi. So if you want, you can note down d pi is differential angle. You multiply with radius, you get a differential length in pi direction you get. So in that way, this one is differential length in pi direction. That is nothing but rho into d pi here. So now you have, I told you, you have to remember differential lengths only. Then you can write differential length vector, differential surface vector, differential volume directly. So differential length in rho direction is d rho. Differential length in pi direction is rho d pi. Actually, this is rho direction. Then small length in rho direction is d rho. Then differential length in pi direction is rho d pi. Differential length, this is total height z. Then small height in z direction is dz actually. So you have to remember them, differential lengths. Now if you want to write dl bar equation and ds bar equation, dv equation, it is very simple, already I told you. So differential length vector in the cylindrical system is nothing but take differential lengths and multiply with unit vectors. So d rho, differential length in rho direction, multiplied with rho unit vector. Similarly, differential length in pi direction is rho d pi, then multiply with unit vector a pi k. Differential length in z direction is dz, az, so meter. So differential surface vector in rho direction. I told you, if you want differential surface vector in rho direction, you leave this because rho will be constant on that. Multiply these two. So it is rho d pi dz. If you want, you can see here. So actually, this is the surface. This is the surface. This one. This is the surface on which rho is constant. Okay. Now for this, this is the what do you say, differential surface vector equation. You can see here, for example, here this is rho, here rho is 0, rho is increasing like this. For a cylindrical surface, I told you already, rho is constant. For example, let us say here radius is equal to 1 meter, then here radius is constant for this surface. If radius is constant, then normal unit vector away from this surface is aero cap, aero cap. So then what is the area of this? Area is nothing but this width into height. This width is rho d phi. You can see here rho d phi into dz, this one. Okay, so in that way, you can see here plus, then differential length in differential surface vector in phi direction means you have to multiply these two and d rho and dz. If you want, you can see here, this is the surface. So I am marking here with blue ink. So this is the surface, right, dear students? This one. So for this surface, of course it comes this side, but area wise I am talking. What is the area of this? This is dz, right? And then what is this one? This is d rho. So d rho into dz. Of course, this surface plus a pi means that side you get. Actually, we can't see that one. So that side we get. It's similar to this side. Anyway, now let us see topmost surface. This surface, this one. Can you tell me what is the ds equation for this? For this ds equation is this one. For this, not ds equation is nothing but this is d rho and this one multiplied with this one, that is rho d pi. So rho into d pi you get. So you can see in z direction you have to leave this one, multiply these two. So that is rho into d pi you get. So this is meter square. Now what is the, actually here you can see small volume is there. Total cylinder has total volume, but this is small cylinder. So what is the volume? What is the volume of small cylinder? This one, this marked one, that is called differential cylinder. Then it has differential volume, that is nothing but multiplication of all the differential lengths. So here you have here length is there, here width is there, here height is there. You have to multiply all of them. So you multiply all of them, rho you will be writing here, then d rho, then d pi, then dz meter cube. So if you remember them, you can easily write them. Now for example, I will solve one example. Find volume of a cylinder of radius rho and height h. Okay. Now how to solve? Take equation of differential volume, that is rho into d pi into dz. Then if you add small volumes, you get big volume. Here in adding means taking integral. How many integrals? 3 integrals. So if you take triple integral, then you get total volume, that is equal to triple integral rho d pi dz. Now actually you have to separate rho terms, rho d rho, separate pi terms, separate z terms. Then here it is given height 0 to h height. Then I told you for circular cylinder pi angle varying from 0 to 2 pi. Here at the center radius 0, final radius is rho here. So this one. Okay, this is separate discussion. Now after integrating you get this one, rho square by 2 you get. So rho square by 2, and this one you get integral d pi is pi, you get 2 pi. This one is h you get, because your place is not there. So if you want, I will write like this. One more step I will write here. See, this is integral rho d rho is rho square by 2, rho varying from 0 to rho. then it is pi varying from 0 to pi. This is z, so z varying from 0 to h. Now you substitute rho square by 2, you get then this is 2 pi minus 0, h minus 0. So the answer is actually 2 to cancel, then pi rho square into h meter cube. So you understood that if you want longer length of long line, then you take differential length and integrate that single integral. If you want any surface area, then you take differential surface equation on that surface, then double integral that. If you want equation of volume, then you write the differential volume equation, then you take the triple integral, you get total volume, like that. Now we have to discuss for spherical system. Okay. So students, now let us discuss differential lengths also, and we will discuss dl bar equation. That means dl means differential length, bar means vector. So we will discuss ds bar, that is differential surface vector. Already we have discussed one example for differential surface vector. I have taken an example. While discussing surfaces, I have discussed that. So dv, actually by definition length is a vector, by definition surface is a vector, but by definition volume is a scalar. So that is why bar is not there. So it is differential volume actually. Okay. Now first let us discuss in rectangular coordinate system. Then we will discuss first we will discuss differential lengths dl bar, ds bar, dv equations in rectangular system. Then we will discuss in cylindrical. Then last we will discuss in spherical. So in rectangular system, let us take one very small cube. Let us take. Okay, like this I am taking cube. I am taking like this, dear students. So you join them like this. Okay. Now here this is origin. This is 0, 0, 0 origin. Now let us take this as a dx, this one. Now this width as a dy you take. This height as a dz you take. Now there is a cube here. Which cube? Differential cube. Differential means what? Small. Small cube is there. Why you got small cube? Because differential length dx, differential width dy, differential height dz you have taken. Then you got a small cube. So in this way, what are the differential lengths in this coordinate system? So differential lengths in this coordinate system, in x direction small length is dx, in y direction small length is dy, in z direction small length is dz. So they are the differential lengths in the rectangular coordinate system. In x direction dx, in y direction dy, in z direction dz. So this is a unit is meter, this is also unit is meter, this is also unit is meter, because they are small lengths. Now if you take dx, dx means a differential length in x direction, and multiply with unit vector in x direction, then this is called differential length vector in x direction. Similarly, you take dy, then multiply with unit vector ay cap, then this is called as differential length vector in y direction. Similarly, you take differential length dz, multiply with unit vector, then this is differential length vector in z direction. You add all of them, you will get total differential length vector equation in the rectangular coordinate system. So you have to remember only these differential lengths. Then dl bar, ds bar, dv you can write simply. For example, ds bar equation we will write. Ds bar equation. So here, dear students, actually already we have discussed what is the surface vector. Surface vector is defined as area of the surface and then normal unit vector to the surface in outward direction. This is the already I told you to remember this one. Now, for example, this is a x-axis and this is dx. This is y-axis. So this one is z-axis actually, dear students. Now, for the front surface, I am drawing here like this. For the front surface, this one I am marking here. For this front surface, ds bar is equal to, now for this surface, front surface, this is dy, okay, and this is dz. Then normal unit vector away from this front surface is ax cap. So actually this is differential surface vector in x direction. That means for that surface x is constant. X is constant. Already I told you, no, like this. This is y axis, this is z axis, this is dy, and this is dz. So here this small surface is there, and this one, this marked one. And for this surface, ax cap is normal unit vector. So differential surface vector is dy into dz into ax cap. So like that. Now what I want to tell you is that if you want differential surface, you remember these things, dx, dy, dz. If you want differential surface vector in x direction, then on that surface, here x is constant. I told you on the yz surface x is 0, x is constant. So x is constant. That is why x doesn't change. Then leave that मतलब उसको छोड़ दीजिए, because this is x equal to constant surface, or otherwise yz surface. On yz surface, y comma z are variables. So you leave this one and then multiply these two. So dy dz. Now you can write ds bar equation in all the coordinate system like this only. So for this surface, x is constant. Then surface vector direction is ax cap. Because normal unit vector to the surface is ax cap only. Now then you leave this one, then you multiply these two, you get a differential surface vector equation in x direction. Similarly, for this surface, here I am writing for this surface actually y here for this surface. This is ds. Actually, this is what ay cap. That is 90 degrees to this surface. Then this is dz and this is dx. So ds is equal to dx dz ay cap. So that is the surface vector. That is why no need to remember them. If you want differential surface vector in y direction, I told you y is constant on that surface. Leave this, multiply these two. So dx dz. And similarly, if you want differential surface vector equation in z direction, then leave this one and multiply these two, dx dy. If you want that surface, that is a top surface actually. So this is the surface here. For this surface actually z is constant. So z is constant surface. So for that, for top surface, this is dx and this is dy. So dx into dy. Then how you get volume equation? So volume equation, differential volume equation, small volume equation. So here, small length multiplied with small width multiplied with small height. So dx multiplied with dy multiplied with dz. So simply you multiply all differential lengths, you get a differential volume equation. So it is meter cube, it is meter square, and it is meter. Once again, I am concluding that differential lengths you remember, that is dx, dy, dz. You take them as it is, differential lengths, and multiply with unit vectors, you get dl bar equation. You leave this one, multiply these two, then you get differential surface vector in x direction. And you multiply all of them, you get differential volume equation. So this is the rectangular coordinate system. Now we have to discuss a cylindrical system. Okay. So dear students, now let us discuss a range of variables to cover all regions of space or otherwise universe. Now one by one we will discuss. This is very simple in rectangular coordinate system, very simple. In the rectangular coordinate system, we will assume the shape of the universe as a biggest cube. Now, already we told you that if you take this as a x-axis, then x is 0 to plus infinity means positive length in the universe is covered. Then here origin x value 0, x 0 to minus infinity means then negative length in the universe is covered. So that is why here x range is minus infinity to plus infinity. Similarly, here origin y value 0, y 0 to infinity means positive width is covered in the universe. Y 0 to minus infinity means negative width is covered in the universe. Similarly, z 0 here, z 0 to infinity means positive height is covered in the universe up to infinity distance. And we don't know where that ends. It keep going, it will never end. Similarly, z 0 to minus infinity means bottom side, that is a negative height of the universe. So, if you take x, y, z from minus infinity to plus infinity, then all the locations in the universe is covered. That is the range of these three parameters in rectangular coordinate system. Now coming to the cylindrical coordinate system, what is the range? Let us see. One by one I will tell. For example, I will take this as a z-axis and this as a y-axis and this as a x-axis. Here on the z-axis radius is equal to 0. So radius 0 means you get z-axis. So for example, let us say here z is equal to minus infinity and here z is equal to plus infinity height. Radius 0 means z-axis. I told you radius measurement starts from z-axis. Now z-axis is what? Infinity long line, because minus infinity, minus infinity, minus of minus infinity to infinity is infinity. So infinity long line that is. Okay. Now dear students, rho is equal to 0 means z-axis, that is infinity long line. Now you increase the radius from 0 to infinity. Actually we have taken this length, we are assuming that as infinity because we cannot go to infinity. So this is infinity. I will reduce a little bit. Okay, like this. This is rho is equal to infinity. This one. So if you take radius from 0 to infinity, actually wherever infinity comes you should not put equal because we don't know value of that. Then you will get a infinity long radius line. Then you rotate that line by horizontal angle 0 to 2 pi, then you will get a circle. Actually like this you get a circle. Then what is the radius of this circle? Infinity. So by rotating this infinity length line like this, you get a circle That means all the locations in the universe on a circular disk of radius infinity is covered. So this horizontal angle 0 less than or equal to 0 less than or equal to pi less than 2 pi. Why equal to is not kept here? Because if you put equal to, then what will happen like this, 360 degrees is equal to once again 0 degrees. Then this 360 becomes again 0. Then range becomes like this, 0 to 0. So that is why you should not put equal to here. That means actually 360 means 0 degrees. 0 is also 0. So 0 should be only one time in the range. It should not be 2 times. If I take equal here, then again 0 comes, 0 becomes 2 times. That is not correct. So here, so dear friends, now by taking rho from 0 to infinity, I got infinity long line, this one. Infinity long radius line. Then rotate horizontal angle from 0 to 2 pi, then I will get a circle like this. Circular surface. Then you put the circles one upon one, एक के ऊपर एक रखना है ये circles को like this from z minus infinity to plus infinity up to this, then we will get a big cylinder, biggest cylinder which covers entire universe. पूरा विश्व को कवर कर लेता है, इतना बड़ा सिलेंडर है वो, उतना बड़ा सिलेंडर है वो पूरा विश्व को कवर करेगा और उसका रेडियस इन्फिनिटी होना चाहिए और उसका हॉरिजॉन्टल एंगल 0 to 2 पाई होना चाहिए और उसका हाइट माइनस इन्फिनिटी टू प्लस इन्फिनिटी होना चाहिए. नाउ स्फेरिकल सिस्टम देखेंगे. स्फेरिकल सिस्टम में यूनिवर्स को सबसे बड़ा स्फीयर मानता है, उसके लिए लिमिट्स क्या क्या होना है वो है डिस्कशन इधर. सो वी विल अज्यूम universe as a biggest sphere in the spherical system. So for that what we do, you take this as a z-axis. Okay, z-axis. You take this as a z-axis. Now for the z-axis, vertical angle is 0. Why like that? Because the vertical angle measurement starts from vertical axis called z-axis. Now you take this as a center or otherwise origin of the sphere. Origin hai. So at the center of the sphere radius is 0 because origin ke liye or origin xyz values are 0. Then r is equal to root of x square plus y square plus z square. Then at the origin xyz 0 means radius 0. Similarly here also on the z-axis, so on z-axis x value is 0 and y value is 0. Then radius rho means root of x square plus y square. So on the z-axis x0 y0, so radius is 0. That's why I told you radius measurements start from z-axis. Similarly here sphere radius start from origin actually. So radius 0 means origin. Then you take radius like this. जितना भी लेंथ ड्रा किया ना उसी को इन्फिनिटी मानना है क्योंकि हम लोग इन्फिनिटी लॉन्ग लाइन ड्रा नहीं कर सकता है. परेशान मत हो जाओ. So we can't draw infinity long line. Let us assume this is unity length. So r is equal to infinity. That means if you take a radius 0 to infinity, you get one line here, radius line of infinity length. This is radius line of infinity length. Now where is that line? On the z axis. So for the z axis, what is vertical angle? 0. 0. Now I will write a little bottom side. 0 less than equal to r less than unity, and this is vertical angle is 0. Vertical angle is 0. This vertical angle is 0 for z axis. Now if I take this radius line of infinity length, then I will do like this. Then vertical angle is increasing. For example, here vertical angle theta is 90. That means pi by 2. Similarly, this is negative z axis. If I do like this, then this vertical angle is 180 degrees. For full circle, it is 360 degrees. But I have taken only half the circle. Now, for half of the circle, semicircle, this angle is pi. You can put equal here because 180 degrees is not 0. 180 degrees is different value. Now, by taking radius from 0 to infinity and by taking theta from 0 to pi, I have got infinite radius. This is 0, infinity. 0, infinity. So I have got infinite radius semicircle. Like this I have got semicircle. I did not get full circle, students. I got semicircle. Now I am showing you here let us take this semicircle and put on the x-axis like this. Now I am putting the semicircle on the x-axis, so horizontal angle becomes 0. So horizontal angle becomes 0. Now I rotate this like this. 1 degree horizontal angle, 2 degree, 30 degree, 90 degree. With that I got 1 by 4th of the universe, because the radius of this is infinity. So 1 by 4th of universe. Now horizontal angle going to 180, half of the universe. Now 270, 3/4 of the universe. 360, full universe. So now you have to take this 2 pi. Conclusion: to cover the universe one time, you have to take vertical angle 180 degrees, horizontal angle 360 degrees. So any one of the angle is 180, other angle should be 360. You can take this also, theta 2 pi, then horizontal angle pi. So this is also correct. One of the angle should be pi, other angle should be 2 pi. But we will take only this one because here horizontal angle definition in the circular system and here horizontal angle definition, both are same. That is why, so we will take this only range. So dear students, here horizontal angle pi, here horizontal angle pi, same. That is why we take that range. Now you have to remember these things, students. This. So anywhere while solving the integrals in a cylindrical system, we get integral d pi. Then always we take pi from 0 to 2 pi. Even if they don't give, we have to take 0 to 2 pi. Don't forget that. In the spherical system, anywhere you get d theta, anywhere you get d pi, then they don't give. You have to take theta from 0 to pi, vertical angle. Then pi from 0 to 2 pi you have to take, even if they don't give. So what happens if you take theta from 0 to pi by 2, then you will get a upper hemisphere. Hemi means half. If you take vertical angle half, then you get half of the sphere. Similarly, if you take horizontal angle half, if you take vertical angle, total vertical angle, if you make this half, then you get again hemisphere, like that. So this is all about the range, my dear students. Next point we will discuss unit vectors. So dear students, now let us discuss differential lengths in the spherical coordinate system. Which coordinate system? Spherical system. I am drawing the diagram here. You see this one. Actually, this one is one sphere. It is not a circle. You take this as a sphere actually. Then this is center of the sphere. Here this is y-axis and this one is x-axis. So this one is z-axis. Okay. Here on the z-axis angle theta is equal to 0. You know that. Now you draw a vertical circles. You draw vertical circles like this. So if you draw the vertical circles here like this. Now this is xy plane. On the xy plane you have this one rho and this one also rho, of course. This one also rho. So this is pi angle. This is rho. This is d pi. And ultimately here you get this one is actually this one is rho d pi, already you know. So this is rho d pi. Already in conversions you have seen rho is equal to r sin theta. You have seen, dear students, you know this. So if you put that here, then rho is equal to r sin theta. You know here rho, in place of rho you put r sin theta into d pi you get. That means here actually, okay, ultimately this is differential length in the pi direction. In place of rho we have put r sin theta. That means r sin theta, it is not pi. So r sin theta actually, okay. So this is in place of rho we put r sin theta, that is correct. Here d pi is there. Now in spherical coordinate system, this is the equation of the differential length in pi direction. So here I am writing differential lengths in the spherical system in the road, first r direction, then theta direction, then pi direction. Okay. So first let us write. Already you have written in the pi direction it is rho d pi. In the cylindrical also rho d pi, here also rho d pi. But in place of rho we have to put r sin theta. So now answer is r sin theta into d pi. Now let us see these two things. Now what I do, I am taking here like this. This is r and this one is theta. Now I will take d theta, small vertical angle I will take. This is total, it is actually r actually total. Now in this r what I do, I am taking a very small length here, very small length I will take like this. So like this I am taking this one, that is a dr actually. What is that? Dr. Now here you see this one, this line you draw like this. You draw the line like this, dear students. Okay. So you draw the line like this, almost circular line, this one and this one line. So this is also, you say this is r sin theta into d pi. Now this is dr, this is also dr. You draw the line like this, you draw the line like this. So almost this is also dr only. This line I am drawing parallel to this one. You can draw like this. Okay, draw parallel to this one. That much. Okay, this one. So this is dr, this is dr. Now here we will draw the circular line like this we will draw. So if you see this one, if you see this one, this one, this one, and this one, you see here actually this is what is this r and d theta. So this becomes I am writing here r d theta. So what is r d theta? Actually differential length in theta direction r d theta. So now this is total r, differential length in r direction is dr. So these are the differential lengths actually. So you have to make this straight line here. Okay, this is straight line exactly. This is straight line. Now you have to draw this line here like this. This is circular line. Now ultimately, actually I will tell you the differential length vector. So differential length vector equation dl bar is equal to differential length in r direction multiplied with the unit vector, differential length in theta direction multiplied with unit vector, differential length in pi direction and multiplied with the unit vector a pi. This is the differential length equation in the spherical coordinate system. Now let us write the ds bar. So if I write ds bar in r direction, you see this one, for this surface I am drawing here. Actually for this surface, this one, radius is constant. So this is for this one. First of all, by seeing the differential lengths I will write. If you want differential surface vector in r direction, you leave this one, multiply these two. So r into r, r square. Then you get sine theta. Then you get d theta d pi. So d theta d pi a r cap. Now I will explain here what is normal unit vector to this one, that is a cap. Now what is ds of this one? So multiply this one, that is this one, r sin theta d pi, and multiplied with this one, multiplied with this one, that is r d theta. So r into r square, sin theta d pi will get it. Like that, actually backside one surface is there similar to this one. Can you see what is the area of this one, dear students? This one. What is the area of this one? This one. I am writing here. So ds is equal to, for this one is what actually, this one is r d theta. And what is this one? That is dr. So that is r into dr into d theta. So you can also see here that this one actually for pi surface that is. So I will write that. First let us complete all the areas. This one I am writing for this one. So I will use different ink for that. So this surface, this one. So for that one, let us write ds. So ds is equal to, this is dr, and this one is actually, this circle line is this one, that is r into sin theta into d pi. It is in the multiplication factor actually. So let us write here. Actually in down direction theta is there. So normal to this is theta. So here you see a theta cap. If I write, leave this one and multiply these two. So that is r sin theta into dr into d pi, you get plus this one, it is backside, it is there. So for that a pi comes, that a pi, then you leave this one, multiply these two. So r into dr into d theta. So ultimately it is a meter square. Now what is the differential volume? This is differential volume actually, differential sphere, small sphere. Multiply all of them. Then r into r square. Then actually it is sin theta. So r into r square, sin theta. Then dr, d theta, d pi. So meter cube air squares. Now actually I am asking the questions you have to answer. So I am using this place. Can you tell me what is the equation of a volume of the sphere? Then answer, you take volume is equal to triple integral dv. Triple integral degree means integrating means you are adding small volume, so you get bigger volume. That is equal to triple integral. Here it is there r square sin theta and dr d theta d phi. Now in this integration, you separate r terms. R terms are r square dr and separate theta terms. That is sin theta d theta, sin theta d theta. Separate pi terms. Now pi varying from 0 to 2 pi, already we have seen for sphere. This is vertical angle 0 to pi and this radius is 0 to capital R. Let us say, what is the question? Find volume of a sphere of radius capital R. That is the question. Find the volume of sphere of radius capital R. Now, that is why radius at the center 0 and the total radius is capital R. For example, here, this is sphere. Radius is capital R, you take this is radius 0 at the center. Now here it is r cube by 3, r varying from 0 to capital R, and this one, this is integral sin theta is minus cos theta, theta from 0 to pi, integral d pi is pi, so this is 0 to pi. Now this is r cube by 3, and ultimately this one is minus of cos pi is minus 1, minus cos 0 is 1 actually, so this becomes 2. You remember, student, this we will get so many times in our subject. The value of this is always 2, so this one also we get that is 2 pi. Again and again we will not solve that. So 2 into 2 pi, 4 pi, so 4 pi r cube divided by 3, that means 4 by 3 pi r cube, meter cube you get. So in this way, if you want equation of long line, then you write equation of small line and integrate that. Similarly, if you want equation of bigger surface, then write the equation of small surface and integrate that. If you want the equation of bigger volume, then you write equation of small volume and integrate that. So for example, what I am telling is that here I will tell you, you see this one, example I will tell. So dear students, actually here if you have a very small line, if you have very small line, you see this one. So what I am telling is integral dl bar. Integral means sum of differential vector gives length vector, bigger length vector. So double integral ds bar. Why double integral? Because two variables are there. Then you get a surface vector, total surface vector. Triple integral dv means differential volume. So then integrate that, you get bigger volume. So these are the equations. So line single integral, surface double integral, and volume triple integral. You see the first example, student. Example. For example, there is a line like this, y is equal to 0 and y is equal to 5. You know what is the length vector of this? L bar is equal to length of this is 5. Then direction of this is ay cap. Now, what I was telling you is that first you take small differential length, that is dy. Differential length is dy. So what is dl bar equation? So dy into ay actually. Now what you do, if you want a total line equation L bar, that is this one, single integral dl bar, that is equal to single integral. Okay, I will write here single integral. Here dl bar is dy ay, then that is equal to integral dy multiplied with ay. So y varying from 0 to 5 here. So you get y 0 to 5 ay. Then 5 minus 0 is 5 ay. You get this one, length vector. That's what I was telling. So in this way, here let us say you have one bigger surface. So for that bigger surface, I will take second example. I will take this example. This is y-axis and this one is z-axis. Here one surface is there. Y value is 3 meter and z value is 2 meter. Like this one surface is there. So what we will do on this surface here, we will take very first, what is the surface vector of this? S bar is equal to area is 2 into 3. Then normal unit vector to this surface is Ax cap. You know that S bar is equal to area into normal unit vector to the surface in outward direction. So that is this one. Now let us see how you get that from differential surface equation. So you take here small width, that is dy. You take here small height, that is dz. Now this is the small area. Now what is the equation of this small area here? So that is ds bar actually. So ds bar is equal to dy into dz into normal unit vector to the surface is Ax cap. Now if you want S bar, so double integral ds bar, I was telling this one, total S means bigger surface, ds means smaller surface. Now that is equal to here double integral. So dy dz Ax cap. So integral dz Ax cap. So here y varying from here, y is equal to 0 and here y is equal to 3. So y varying from 0 to 3 and z varying from 0 to 2. Here z value is height is 0. Here maximum height is 2 actually. So 0 to 2. Now you get integral dy is y varying from 0 to 3. Integral dz means z varying from 0 to 3. Ax. Now you get 3 minus, this is 2. 3 minus 0 is 3. 2 minus 0 is 2. So that is 3 into 2, 6 Ax you get. So that one only. So actually, if it is very simple surface, you can do like that. But for complicated surface, so this is the procedure actually. Okay, dear students. Now after this, we have to discuss what is the positional vector. Now already we have discussed for volume. So in this way, you take equations of differential length and integrate that, you get total length vector. So if you take equation of differential surface vector, then double integral that, you get equation of S bar. And you take equation of dV and triple integral that, you get total volume. Now actually I am going to tell you positional vectors. So positional vectors, actually positional vector means OP bar. O means origin, P means general point. So in rectangular system, if you see, actually this one is y axis, this is x axis, this is z axis. Let us say here one line is there like this. This is point O, this is point P. In the rectangular system, general point is x comma y comma z. So this is called OP bar. OP bar. It gives the position of this point with respect to the origin. So here it is x, y, z. Now in mathematics subject, OP bar, actually OP bar definition is arrow mark is towards point P. So P is x comma y comma z minus of origin is 0 comma 0 comma 0. So here x minus 0 into Ax plus here y value minus here y value into Ay. So here z value minus here z value into Az. So you get positional vector x Ax plus y Ay plus z Az you get. So this is the positional vector of point P with respect to origin. So now if anybody wants what is the distance from here to here. So let us say this distance is r. Now what is that r? R is nothing but the modulus of OP bar. That implies r is equal to root of modulus of this means x square plus y square plus z square. So I am taking this is the distance actually from here to origin to this one. And distance is r. So that r is root of x square plus y square plus z square. Now let us write the positional vector in the cylindrical system, dear friends. So with respect to origin, what is the positional vector in the cylindrical system. You see this one actually, you see this one, cylindrical system positional vector. This is y-axis, this is x-axis, this is z-axis. On the z-axis radius is 0, so here also radius is 0. Now I am taking one line like this. If I take one line like this, this is OP bar point rho comma pi comma z. This is origin. Actually, origin is 0 comma 0 comma 0 in the rectangular coordinate system. Now in the cylindrical system, this origin becomes 0 comma pi comma 0. If you convert this, this is rho pi z. This is x y z. Now x is equal to rho cos pi and y is equal to rho sin pi and z is equal to z. Now in the conversions you get here rho value is 0 for this point, so 0 into cos pi is 0 and rho value is 0 here, 0 into sin pi is 0 and z value is 0 here. So this is rectangular coordinate system origin, this is cylindrical system. So here OP bar means point rho comma pi comma z minus 0 comma pi comma 0. So that is rho minus 0, rho a rho, pi minus pi 0 plus z minus 0 into unit vector. So this is the positional vector of point P with respect to origin. So if you take magnitude of this, then you get a distance r here. This distance r, total distance now from O to P is r. Let us say r is the modulus of OP bar. So r is equal to root of rho square plus z square. Now you students know that rho square is x square plus y square and this is z square. Actually you know this one, rho is equal to root of x square plus y square. So rho square is nothing but x square plus y square. So here distance and here distance same. In conversions, xyz point and rho pi z point both are same, we have seen. Similarly, no need to discuss that if angle pi here on the same line angle is pi here in cylindrical system. So that is why angle terms do not come in the position vector with respect to origin. Similarly, in spherical system, theta by angles doesn't come. Simply r is the positional vector with respect to origin in the spherical coordinate system. So in the spherical coordinate system, if you take this, this is y and this is x, this is z in rectangular system. Now if I take one point here, if I take one point p r comma theta comma phi, then this is OP bar. So here this is origin in rectangular system x comma y comma z, but in spherical system 0 theta phi, because you know that x is equal to r sin theta cos phi, y is equal to r sin theta and sin phi, and z is equal to r cos theta. So if radius is 0 here, so this is actually r theta phi. So if radius is 0, then all are 0 here. That means this is origin in what do you say, in rectangular system, this is origin in the spherical system. So here this point is also in spherical, this is also in spherical. Now OP bar is equal to point P r comma theta comma phi minus origin 0 comma theta comma phi. Now r minus 0 into ar, so theta minus theta, pi minus pi. So you get r here. So in this way, OP bar is equal to r you get. Then what is the this distance? I will call this as a distance b. So what is this distance? Distance is equal to modulus of OP, that is equal to root of r square, that is equal to r. Again, already you know that that r is nothing but in a rectangular system, in conversions we have seen there is x square plus y square plus z square here, students. Okay, so this is the thing. So ultimately here positional vector in rectangle is OP bar is equal to xax plus yay plus zez. Here rho a rho plus zez. Here r a r you get. So that is all about the positional vector, dear students. Okay.